Depressed to get this up on the screen, apparently. Welcome to the second part of our university session today. My name is Shaun Smith. I'm a product manager for Oracle TopLink with Oracle. And I'm going to talk about what's new in JPA 2.0. So that's the specification that's currently under development. It's not complete. There's a number of drafts that have been put out. And I'm going to speak about pretty much what's been going on the last year. So maybe you've heard last year there was an update on JPA 2.1. I'll give you sort of, mostly, I'll talk about what's happened the last year. I'll talk about a few things that are that have happened over the course of the draft preparation, which I think are interesting still. Now, so I've been with Oracle about almost 7 years, but I've been involved with Java Persistence for about 12 or 13, and I started out myself with TopLink for Smalltalk in 1997. So I've been kicking around the Java persistence, the persistence space for a while. It's kind of neat to see the spec eating up more of what a lot of people are doing in implementations out there for JPA. I apologize, I have a bit of a cold. Whenever I come to Devoxx, I get a cold, and then they strap a microphone to my head right beside where I cough. So I apologize if I get like a blowout of the speakers if I cough and do that. Okay, we'll skip that Oracle thing. So the topics I'll talk about today, there's schema generation, there's converters, unsynchronized persistence contexts, query enhancements, and then sort of status of where we are today, and then sort of where we're going next. Now, if you're coming to this talk, this is like really high on the nerd level. Okay, so we're talking about Java persistence, API specifications, and changes to that spec. So it's pretty nerdy. This isn't even like an introduction to JPA. This is detail. So if you're staying, you get a really high rating on the nerd scale there. Probably a 9, I think, out of 10. So schema generation. I'm just going to talk about these topics. We'll just skip over a few of them. There's a few examples here. I actually had promised to bring, in the abstract, I promised to show some code running on the reference implementation, EclipseLink. But I took a look at what's been done so far, and I didn't think it was very sexy. Watching SQL come out of a transcript in a console isn't really exciting stuff. So we'll just talk about a few things and show how things are configured. So the first topic is schema generation. So what is that? So it's the generation of database artifacts, right? So tables, indexes, columns, generators, sequence generators, tables, generators, etc. And database, the name itself is a little bit misleading because a schema, we talk about schemas in terms of the things in it, but often a schema is allocated, space is allocated to a user, right? Their space. So we're talking about schema artifact generation. And the utility of this has a number of different places it's useful. So as a developer, I like to build Java and object-centric applications. So I'm going to work on Java applications, nice object model, nice domain model, and then as I'm developing the application, I will use schema generation to generate the database that will let me persist the objects I'm working with. Right? So I'm very object-centric. And so schema generation is nice in that I can use it for prototyping to generate the database that backs my application I'm working on. Right? The database will match my model. I like that quite a bit. I don't think in initial prototyping phases, I'm not thinking about database structures and too much. I'm thinking about the Java objects. As I'm iterating through the application, building the application functionality up and expanding the domain model, then of course this is useful to keep regenerating the schema, to let the schema evolve to match my requirements. And then at some point you're going to move into production. Now production isn't dev, right? And there's a lot of DBAs. So schema generation is useful, but you're probably not going to just generate a bunch of schemas from your domain model and then send it off to the production database. That's probably not how it's going to work. And we'll look at how that's handled with JPA spec here. However, in production, in a cloud environment, it might be the case that we deploy an application instance into a cloud, and we do want to actually, in production, generate the database artifacts on the fly. It makes more sense in sort of a dynamic cloud environment, but in sort of a production and enterprise environment, typically people aren't going to do this so dynamically. They're going to take a good look at that schema before it gets put into production. So schema generation, we could generate write into a database, which is sort of how I typically work. You could generate SQL scripts, which you could then run against the database to define the schema, or you could do both, right? You may generate schema from the ORM mappings themselves, and we'll look at sort of how that works. But there's a number of defaults in JPA that say, tables should look like certain things and columns should have certain names. So we can generate right from the JPA classes, JPA map classes, or we could have SQL DDL scripts. So we could have just scripts that you've prepared manually. We want to incorporate that into your workflow. That's possible. And when it happens, it could happen before you deploy your application, or could happen at Entity Manager Factory creation time, so when you actually bootstrap your application. So there's two times when it could happen to you. So who creates the actual schema? And we're talking about this, not the artifacts that are in the schema, but the actual database schema. You could be creating the schema, or your administrator specifically, creating the actual schema. The container could allocate it. So again, in a cloud environment, it's possible you could allocate schema space for a particular user or an application on the fly even. It's also possible for the persistence provider to do this work. And the same is true for tables and other artifacts, right? All the same things. So we get schema space, table space, then we get the actual artifacts generated by either yourself, container, or persistence provider. So what does JPA 2.0, what do we propose to support? Well, really all the things we just discussed. We're going to support the generation of schema either prior to application deployment and execution, or as part of the Entity Manager Factory creation. We're going to be able to let you generate schema from the mappings, either annotations or XML, or of course combination of the two. And we're also going to support DDL scripts, so executing DDL scripts that you may have as part of your application. And there's sort of 2 targets or 2.5 targets, the database, scripts, or both. You could generate into both. And this is very flexible, and you'll see there's a lot of configuration options here to allow you to control exactly how the schema generation is going to work. So we have some APIs around schema generation. The first is a new method called generate schema. It goes in the persistence class. Persistence is the class you use in a Java SE world to bootstrap your application up. So you go persistence dot, typically create Entity Manager Factory, and then you Entity Manager, and then you Factory, and then you go from there. There's a new method, generate schema, which you can call without actually bootstrapping persistence context app or your Entity Manager Factory app. You can call persistence dot create schema. You pass it the persistence unit name and any properties, and it can generate the schema for you. So it's just a utility method that does that prior to application deployment. The create Entity Manager Factory method can also do schema creation. So if you know create Entity Manager Factory, you can take a collection of properties. So you can pass a map of properties in. You can pass in that map any of the properties we're going to look at in a second here, or you can put these other configuration properties into your persistence XML. They can go there too. If you're in a container, the contract between the Java E container and JPA providers uses a different class. They use, well, they call it a different method, I should say. They call create container Entity Manager Factory, and that's the same. It's basically the same thing. Has the same API or same signature as create Entity Manager Factory, but it's just called by the container and passes in properties and can be used to, again, create schema. So either way, whether you're doing it yourself in the SE world or an EE world, the same sort of either upfront creation or on creation generation is possible too. So all the properties, and there's quite a few, like I say, will control how all this happens. So whether we create up front or create after the fact, and where we create to and from and what we use. And again, I mentioned before, you can package some DDL scripts, and we'll see how we can basically identify those scripts so that they're sourced properly and executed on the database when you boot up or when you create the schema. So here's the first of the few. So we have schema generation action. So everything is JavaX persistence dot something. So this is schema generation action. Here we can do nothing, none. Create tables and or the other things, or drop and create, or just drop. And so you may have some useful little scripts that are kicking around to not actually bootstrap your Entity Manager Factory, but to using the persistence create schema to just drop your schema or create your schema or drop and create. So you can actually use that class with these properties to just sort of drive the generation or cleanup even of schema. The second is the target. Okay, you're going to generate. What are you going to generate, right? The first step is creation or drop in create or create. Then there's where to generate it to. So should you execute this on database directly, or should you just generate scripts that could be used later, which you're going to set aside and run as part of maybe an environmental setup or some sort of script you have. So you can do either and both, right? Database directly or scripts and database. Of course, if you're going to create on database, you're going to have a database connection, and that'll come up in a second too, but it's pretty hard to create against a database if you have no connection to generate on. So for the DDL here, we have create scripts and drop scripts that can be generated, and you can pass as a property if you're bootstrapping your entity manager factory in that property map I mentioned. You could pass in some objects. So people are not used to this that much in JPA. Certainly the providers offer the ability to pass in objects as the argument or the value associated with a key. I know in EclipseLink, that's something we do. But typically people use the strings. So if you are in a persistence XML file, of course, all you can have is strings. So you could say something like create script target, and you can provide a URL of a file that we're going to write to. If you're in code, you can actually pass in a writer object as the argument, and that writer will be used as the target for the creation script, or the drop script in this case. So you have a bit more flexibility there to sort of script things together in code over the static config in your persistence XML. The other three are, if you don't have a database connection, as mentioned, if you don't have a connection, the provider can't figure out what database target word we're going to generate schema for. And of course, schema generation is very database specific, right? The types of the columns in various databases, they vary. Some of the namings, uppercase, lowercase, a number of things vary across databases. So we kind of need to know, if we don't have a JDBC connection, what database we're going to target. So the schema generation has to be told up front. And here's the properties we can do it with, right? So product name, major version, minor version. The spec actually says that these values must be equal to the values returned by the JDBC driver if you ask it. I don't know where that is in terms of the implementations. Certainly, we all know this in the past, right? So TopLink and Hibernate, or EclipseLink and Hibernate, OpenJPA, all have their own names for their databases. Basically, they're dialects, right? So I know in EclipseLink we have Oracle, Oracle 10, Oracle 11, Oracle 12, and so on. I'm not so sure that's exactly the name the JDBC driver gives back, even though I know that in EclipseLink, when we talk to a database, we ask it, what is it? And we figure out what to do. So we're sort of doing this under the hood right now, but some of these names are going to surface. The actual names of the database drivers are going to surface rather than these nice names that we've been using in the past that we just use as a shorthand. So that's something to look out for if you're using this. You have to get your database name right. Now, there's some more properties here for these scripts. So let's say you want to provide some scripts to create or drop tables. Rather than having the JPA provider figure out what to do, you say, here's a SQL script. Please run this when you create any manager factory to initialize database. We have the create script, the drop script, and again we have this choice of either passing a reader or a URL. Again, in persistence XML, you're going to have to provide the URL because it's going to have to be a static string. But at runtime, if you're passing properties, you could pass a reader. So you could actually very dynamically feed sources sources of files to the JPA provider, or you can give us targets to write onto using these properties. And the last one here is sort of after you've created all your schema, maybe you want to initialize your database with some content. Right? So maybe this is actually quite useful, certainly in a test environment where you may want to run DDL generation, drops and creates tables. Now we're up to speed. We have a script to load some reference data, some static stuff that's there for all your sort of acceptance testing or whatever you're doing. We could bulk load that script. And I believe Hibernate has a feature for this out of the box today. And I actually blogged about how to do this with EclipseLink. It's just a little hook to basically get a callback after DDL generation is done to let you load your script. So now it's going into the specs. So it'll be a nice standard uniform way for you to express this desire to load a script and have it run against the database. So it's quite convenient. Again, this all sounds very dev test-y to me. I certainly wouldn't probably be doing any of these things in prod. So the schema generation itself. So in JPA, the metadata is divided into two rough categories, right? We have logical metadata and mappings, and the physical. So we have logical, we have entities, persistent objects, we have basics, the simple fields, ID, of course, made to ones, relationships, all that kind of stuff is all very logical. On the physical side, we're talking about tables, columns, indexes, constraints, all those kinds of physical things. And typically, well, actually, I should mention ID is in both columns. Physical and logical, it's both conceptually the ID of an object, but it's also physically the primary key on the database, right? So there's sort of both. But we can typically deduce the physical from the logical, right? And there are rules that we can deduce, and there are rules for this. And I think on the next slide I will talk about that. So here's an example. So for a table, in the first couple of bullets there, the table name, if we generate schema, will be derived from the entity name, so the JPA entity name. The entity name is derived from the class, a short class name. So if you have just a class employee, then the entity name is employee, and therefore the table name is employee. That little intermediate step there is obviously not always obvious, because people don't often name their entities anything. But you could take an entity class called entity, or sorry, called employee. You could call the entity emp, EMP, and the table will be called EMP by default. Excuse me. Just to mention, just as I go and say that, the other thing to know is if you do define the name of the entity over the class name, that name that you define it to be should also be used in JPQL. So in the query language, you refer to things by the entity name. It's kind of subtle, but it's not the same as the class. Although again, mostly people just default to the same. So we derive things, right? So if you give us just a bunch of logical annotations, logical mappings, we will deduce and generate schema based on those logical mappings. However, you can override, right? So there are annotations for table, column, join tables, join columns. There's a whole bunch of physical annotations you can use to override that, which is nice in the way JPA works, in that you don't have to specify that much. You can specify just the basics, and then you sort of program by difference, right? You just configure, or you configure the things that don't match the defaults. So you get away with a lot of short customizations. So an example here is a one-to-many mapping. One-to-many, a unidirectional one-to-many, by default will use a join table, right? Because the target table doesn't contain a foreign key back to the parent necessarily, may not. So we put in a join table. You can override that with a join column. You can say, no, I'm going to use a join column on my one-to-many because I know that the target has a foreign key. Let me show you. I think I have an example here. So here we are with a canonical employee again. We have an ID. It's going to map to a column called ID by default. The column name will match the ID, match the name of the field, ID. We'll also must mark that as primary key on the table for doing schema generation. String name will be a name column called name, which will default to varchar 255. And made to one, in this case, is employees all work for or are assigned to a certain department. We will get a foreign key column. So we have many employees, all of which refer to a single department. And so all the employees tables will have a column containing the department ID. And that department ID name is derived from the name of the field and the foreign key and the primary key of the target. So you can't see it here, but department's ID is ID, hence the name dept_ID. This can get really nasty, and this is where you often see overrides for physical names in JPA. Is some of the defaulting can give you really, really long names. So we start tacking together the target name's primary key field with the classes, and they can get very large. So dept_ID is a pretty reasonable short name, but sometimes they get quite long. Okay, so if I had that unidirectional mapping, I want to override the default. I'm not going to use a target foreign key. I'm going to switch it up. So I've got an employee here. I've got the department. In this case, he's got again name, string, whatever. He's got a collection of employees, one-to-many, a set of employees. Now, typically, what you see in JPA is a mapped by. You see a one-to-many with a many-to-one back. You see, because in relational, of course, you have both associations are valid. So typically, you see one-to-many to employees, and the employee has a many-to-one back. And on the one-to-many, you'll say mapped by department. In other words, the employee relationship is defined on the employee relationship or collection of employees on department. The join information is on the employee, right? Because he has a menu one back and he has that column containing the department ID. But in this case, I can say, well, what if we didn't want to model it that way? What if we didn't want employee to actually model its relationship to department? So we strike that, it's gone. I can't do a mapped by anymore because I have nothing to join it. So I'm saying that a department has a set of employees, and the only way to do it now is with a join table. I need another table to hold on to the join information. Because it isn't on department and it isn't on employee, I'm going to put it in a join table. So by simply doing a one-to-many and having nothing else, we imply a join table. So point being that as I change the logical, I delete this many-to-one, I'm going to affect the physical, right? The physical database that I'm going to generate is going to change. And now I'm going to change it a little bit. I didn't like that last one. I didn't like that extra table. I still want two tables. I want employee and I want department. But I don't want to map the back pointer from employee. So I haven't got that many-to-one. It's gone. What I have to do here is say, okay, department's got a collection of employees. The employee table has a column called department ref, dept ref here, that points back to me. It's a foreign key back to me. So on the one-to-many, I define the target foreign key, the key on the target that points back to me. And so now I've eliminated, once again, you can see that line here. It's unfortunately in blue. I can do it with a mouse, I think. Or I can't. Okay. After the one-to-many there in blue, the @join column is going to change this from a join table to back to a foreign key again. So I can really control the schema I'm going to generate from just a few annotations. Another new annotation is index. So we didn't have this in JPA 2, although I know in EclipseLink we added it, Hibernate has had it. It's a common extension from JPA providers. People wanted to find indexes, and so it's being rolled into the spec. And this is how, again, this is how things work. So the spec covers some percentage of common practice. You find there's some innovation by the various providers out there. They all try different things. We agree that, yeah, this is a useful feature, and it gets pushed into the specification for portability. So there's a lot of this going on. I'll bring up some of them as we go forward, but it's nice to see common best practices or commonly agreed upon features being pushed into a spec so that you can have more portability of your applications and not become so coupled to the underlying JPA provider. So in this case, indexes. You can go and put an index on various physical annotations like table, secondary table, collection table, all the table-related annotations. You can go and put an @index. You're going to refer to column names, and so you are going to bind yourself to certain column names to do this. So you have to be careful what column names you're using in these annotations. And the ordering is going to be preserved. Let's see here. So here's the definition of the annotation index. It has a name, which defaults to nothing, no need for the name necessarily, a list of columns, and whether they have to be unique or not. And then you see here the sort of the BNF is index column is a list of indexes or a list of names, and they can be ascending or descending. So let's see here. Here's a good example. So I have an employee. I'm going to put a couple of indexes on the employee table here, on the name column and the department ID columns. And you notice it's enlisted in the index. Indexes collection here of table. For me, this is actually odd. It looks odd to me just because I'm so used to using table to override the name of the table. So usually it's table name equals some name to match the database, which may have prefixes and all kinds on the name, and I have a nice simple like employee class. What's weird here is that table name isn't specified. We're actually just going to customize something else. We're going to add indexes. So if we generate this DDL from this, we'll get an employee table, but we'll also get some indexes generated for those two columns. Simple as that. Some of these aren't complicated. That's the thing, right? This is not a majorly complicated feature, but it's nice to have, right? It's nice to have these things. Foreign key lets you override the default behavior of a persistence provider when it generates DDL. So typically when you've got relationships like we have department and employee, we generate DDL. I know in the case of EclipseLink that I work on, we will generate foreign key constraints out of the logical relationships. We understand the joins, we put the constraints in place. Foreign key lets you override that and take more control. So if you know what you want to do here, of course you have the power to take over. It lets you either actually turn off a foreign key constraint or define your own foreign key constraint instead of what we would do by default. So it gives you a bit more power. And the note is used with caution because you're into database-specific DDL at that point. And I'll show you an example here. So here's the annotation. There's not much to it. It has a name for the constraint, a foreign key constraint we're going to generate. We have a string, which is going to be the actual definition we're going to pass to the database to generate the constraint. And we have also a flag to disable, and I'll show you how that works out here. But again, this is database specific. So when you use this annotation, if you were to go from, say, SQL Server to Oracle or DB2, this code might not work anymore, right? This definition. So here's the example, right on the bottom here, foreign key, manager ID, references manager, on delete, set null, all that business. It may or may not be portable, right? What's nice about using the provider to do the foreign key constraint generation is that it is portable. So for example, if I have EclipseLink targeting DB2, we'll generate the appropriate foreign key constraint DDL for it. If we then say, oh no, actually we're going to run this application on Oracle, generate DDL, it generates the appropriate constraint syntax. So taking control yourself has some value, but it does reduce your portability. And I don't have one here. So backing up, what you can do, I didn't show, is that flag that says disable. I think it's back here. So disable foreign key defaults to false. If I said true, then actually it would suppress creation of the foreign key constraint. So you may want to actually suppress it. For whatever reason you don't want that RI rule put in place, you can actually suppress the generation. Now, that's a portable feature, of course, just suppression. I should say there's a mic over there. In the last session with Jan, it was pretty hard to hear people in the back. So if you can try, if you have a question, and interrupt me, that's great. Put your hand up. I can actually see. Usually at Devoxx, the lights are so bright. You know, it's like I can't see anything, but I can see you. So if you have a question, put your hand up. I'll try and look up. And if I can't hear you, we have a mic. And we can go over that. OK, that's schema generation. So that's actually a big feature. The good news for the implementation of that is almost everyone does this already, right? So certainly this functionality you can get for Hibernate and EclipseLink all have schema generation. All that the providers have to do now is upgrade a little bit to meet the specifications way of specifying it, right? So the nice thing with a lot of this stuff is there isn't a lot of engineering work to get these out to you in JPA 2.1 compliant products. It's just a matter of, I would say, just aligning themselves with the specifications way of describing some of these things, which is good. Oh, so converters. So this is a feature, I've been using this feature for like 15 years, so I'm glad it's in the spec. Converters are allowing you to translate between or convert between database data format or type and the Java format or type. So it's often the case the database contains data that's in a format that's not quite right. The canonical example we usually use in EclipseLink world is a database that contains a flag M or F for male or female, but in Java it's a string male or female, something like that. So it's actually quite different. And so we want to translate from some database encoded value to a Java representation we prefer to use, possibly even an enum, right, which is obviously a more modern approach to this. So this is a long-standing need. Everyone has this. In EclipseLink, we call them converters. We call it convert. This is actually very similar to EclipseLink. Hibernate talks about user-defined types. It's the same thing, pretty much. This only works, however, this version of in JPA 2.1, it only works on basics. It works on simple valued properties and on properties of embeddables, but simple fields like strings, ints, and basics. So the idea is we have an interface here called attribute converter. It takes two types, X and Y, and a converter has a convert to database and convert to entity attribute. So basically, it just converts back and forth, right? It's a function that just translates one to the other and then back again. And as objects are read from database, the code that people can provide for an attribute converter will be invoked to convert, and the object you get back from, say, a read operation will have the converted value in it in the object. And if you were to update it or put it back, the inverse, the convert to database column method would be called on that property. We'll translate it back to a database format, and it'll go in as part of the SQL operation. The annotation itself here, a converter, which we'll see how this is used, has an auto apply to false. And I'll show you what that means. Because you can define a converter between data types, and by default, we don't necessarily want this to be happening everywhere. And I'll see why. I think in the example we have is a good example. So we don't want the auto apply to occur, but this is not the perfect order here to explain how this works. Let me jump ahead to the example and then back up to the slide. So here's a converter class. I think this is not bad. This is a converter that converts weights, or technically mass, I guess, if it's in kilograms. The database is clearly containing kilograms, and the application must be a US application. I'm from Canada, we use metric, so this is strange for me too. So it must be a US application because they're the only ones who are using pounds, right? Even the British are using kilograms. So the database contains kilos. As we read the data into Java, we must convert to pounds. Java uses pounds. We put it back to disk. We convert the pounds back into kilos again. It goes to the database. So this is a simple converter, right? Two-directional, bidirectional conversion. It's double-double. This is the key thing, right? It works on doubles. What that means is, if we have a double attribute on an entity, this can be applied. And stepping back now to that previous slide, the auto-apply setting would make it that if you had auto-apply true, it says any double attribute on any entity in your persistence context will have the converter applied, which would be bad because doubles are frequently used for all kinds of things, not just weights, right? If it were a weight object, it'd be one thing, but it's double. So that's why they have this auto-apply off idea, right? So it defaults to false. And so we can see it being used here. So here's the converter being used. So I've defined this converter class. I've identified it, defined it. Now I can use it. And so I just put an @convert on a particular double, in this case shipping weight, and I identify the converter class I want to use. So I've now attached that converter to this particular field. And again, like I say, if I had auto-apply true, I wouldn't have to do that. It would just happen. But it would happen probably way too much and everywhere. So this is quite good. So this is quite simple. You can make up your own converters for data types. You might be converting between, I don't know, string formats for representations of phone numbers. I don't know. Maybe formatting for what you want to show in your Java object. But this is a really useful feature. I find it one of the most used features out there, just for practical reasons, because Java doesn't necessarily match database exactly. And I was actually really surprised when it wasn't in JPA 1. I couldn't figure that out. How could they not need this? Oh yeah, sorry. Here's the auto-apply true example, right? So if we define the converter with true, I may then want to turn it off. So if I said the converter is applied everywhere, you find a double, I may now, instead of applying it on case-by-case basis, I can disable it on a case-by-case basis. So you have the best of both worlds. You can configure it either way, magically everywhere or only where you say, and you can control on a particular case-by-case basis whether it should apply or not. So here's an example. It's quite good. Okay, persistence context. This is a meatier topic, and it's quite a nice enhancement. So I'll dig in here. So in JPA 1.0 and 2.0, we had container managed persistence context, and we had application managed persistence context. And container managed are transaction scoped, right? So scoped the JTA transaction. That means that in a transaction scoped persistence context, like an entity manager manages your persistence context. When a JTA transaction is committed, your entity manager is committed. So all the work you do, any interaction you have with an entity manager will get committed when the JTA transaction is committed. And in an EJB world, that's typically at the end of a method, some EJB method at some point, you'll commit the transaction. We have an extended persistence context, which was a way for us to span multiple JTA transactions. So we could have a persistence context on, say, a stateful session bean that, even though we're interacting with it through multiple transactional methods, we don't commit that at the end of each of these, the JTA transaction. We wait to a certain point till we're happy, then we can commit it. So that's a nice feature, but we're going to build on that with Unsynchronized in a second here. And these container managed persistence contexts are automatically enlisted in the JTA transaction. right? So if you create an entity manager or get one injected, it's going to be attached to the JTA transaction automatically. In the application managed persistence context, again, they can span multiple JTA transactions, and they would be automatically enlisted in a transaction if you created it when there was a transaction. So if you're in a method in an EJB where there's no transaction active and you create an entity manager, it would not be attached. There's nothing to connect it to. You could join it later yourself manually. But if you create an entity manager and there's already an open transaction, automatically it will hook up. That's just the way it works. It hooked itself up to the transaction. So these are all nice default behaviors, but they don't work all perfectly for some use cases. And again, at every commit, any entity manager that's connected to a transaction will get flushed and committed to disk. So now we've introduced this new persistence context type. Or I should say, it is being introduced and will appear when Java EE 7 ships. So the idea is an unsynchronized persistence context is not connected to the JTA transaction unless you connect it yourself, unless you join it. Okay, so this is just going to be, you're going to create one of these persistence contexts. It's going to live independent of the JTA transaction. It can be either injected for you, so being container managed, or you can instantiate your own using the entity manager factory yourself. You can do everything with it except for certain things that require you to have a database transaction. So imagine you've got this, if you've got a persistence context or an entity manager, and it's not connected to a transaction, it means you're also not connected to any kind of transactional resources like a JDBC driver or connection. So when you have an unsynchronized persistence context, you can persist objects, you can remove, merge, refresh, you can do a whole bunch of things that don't require you to actually have a database transaction open. Okay, certain things do, like a flush means I must have a database transaction to push changes. If I want to lock something with a pessimistic lock, I have to have a transactional connection. And so what you really have is sort of an object level world, right? It's an object world disconnected from the database transaction. It turns out, this is just sort of an aside, EclipseLink works this way today, pretty much. EclipseLink is very stingy on database connections, so we really, really try not to use them. So when you get an entity manager in EclipseLink and it's hooked up to the JTA transaction, we have read pools and write pools. So you'll be doing all your reads through a read pool, and it's non-transactional. The moment you do something like a flush or a persist or anything that requires you to begin a database transaction, you get a connection from the connection pool. You get an exclusive connection. So for reasons of scalability, we can really scale an EclipseLink application because every entity manager doesn't have an exclusive connection. And some providers do that. Every time you get a session, you get a connection. We just don't do that. So this behavior is actually quite similar to what we have, sort of what we have in EclipseLink today. So it scales quite nicely. And of course, this is great because, yeah, if you don't have a database connection, you're not using up resources. There's a whole bunch of upside to doing this. So anyway, you can do this. There's certain things you can do and can't do in an unsynchronized persistence context. Now, why would we want one of these things? Right? This is the question. What is this unsynchronized thing? Why wouldn't you want to be hooked up to the transaction and committing when the transaction commits? And the biggest thing is this sort of modeling of conversations discussion. So an example I have, we'll go through this, but imagine you have this back and forth between client, through some JSF pages or whatever it is, through EJBs, and you have some state on the server. So the classic canonical example is the shopping cart, and that's the one I'll use. You have a shopping cart, and you're changing your shopping cart. You're doing all kinds of things with the shopping cart. You're managing some state, but you haven't bought anything yet, right? You haven't said, I'm going to buy. When you buy, then you may write a database transaction to purchase. But until you actually hit the buy button, you're just sort of managing state, okay? And in JPA right now, prior to 2.1, because you're always connected to the transaction, or mostly connected to the transaction, it's harder to model. You can actually model it. I think I'll walk you through an evolution of a shopping cart application here that moves from the old way to the new way. You can see some of the advantages. The third point here is you may want to have transactions on other resources. This is really the kicker. I think that the modeling conversations is doable today in 2.1 and JPA 2, but having multiple transactional resources used in your EJBs, some of which are connected to JTA transaction and committing, and some things which are not connected and not committing, is harder to do. So this is actually quite good. And also this in EJB, we're going to propagate unsynchronized persistence contexts. Even though we're not going to be tied to the lifecycle of the JTA transaction, as you move between beans and you're passing control, we want these unsynchronized contexts to flow with you so that you can keep working with them. So, sorry, it's loud. JPA2, okay, container managed extended persistence context. This is the currently what you can do with extended. So notice I have a shopping cart EJB here, and transaction attribute is never. So none of the methods are transactional, right? There are no transactions here. And so I've got an ending manager, and presumably they'll call start to shop first. So we'll get a customer ID, we'll go find that customer, and very optimistically we'll create an order to track what they're going to buy for sure, right? So we have an order object, but there's no transaction. Right? I have an ending manager, I have persistence context, but I have no transaction at this point. Over the interaction, the conversation with the user, they may go browsing for books by author, browse for some books by subjects. No transactions are occurring, we're just reading stuff from the ending manager, that's fine. On add to cart, we create an item, we put it in that order we created, so we have some state we're managing. And then, when they finally want to buy their order, so they've got their books or whatever it is in their shopping cart, and the orders are all items are attached to the order, we put on that particular method, confirm order, we put a requires new. So we force a transaction to be begun. And because we have a persistence context, it's extended, but it's synchronized, because of the transaction, we're going to commit this, right? We're going to commit this to disk. So it's going to go for us. So the point being that I'm playing with transactional boundaries here on the EJBs, right? I'm trying to control this conversation, saying this operation is going to require transactional behavior. Everything else, we're just going to keep it tracked in memory. It's just, it's just going to be happening on this stateful session bean. Okay. So now with an unsynchronized persistence context, it's a bit different. He's extended, or she's extended, I don't know, it's extended, and it's unsynchronized. So that means that it's going to survive transactions, and it's not going to be hooked up to any particular transaction. It looks very similar. It's exactly the same as before. We start to shop. The only difference is that when we get to the end point. So in this case, actually, I should point out, if you look, one more change I made here, which I just missed, was the methods are transactional, right? So by default in EJB, if I have a stateful session bean, all the methods will be transactional. So start to shop is a transaction. Nothing happens here. We do a find, but nothing's going to be committed to disk. That order is unmanaged. Finding books, these are all in transactions, but causing no trouble for us. Adding to cart, again, there's nothing to commit. But when we get to confirm order, I can take my unsynchronized entity manager and say, hey, I'm going to join the transaction now. I'm ready to do some database interaction. I want to commit my changes. He joins the transaction, and then as the method exits, the JT transaction completes, and my order is written to disk, right? My customer goes to disk. So this is one way to do it, right? I'm working in a transaction-free, or a transactional world, but my entity manager doesn't participate until I say so. So at this point, it's time for him to participate. So I have to call it join transaction because it's not automatic. I couldn't do this in JPA 2. Excuse me. I couldn't do it in JPA 2 the same way. Now, this is where it gets interesting. And this is, I think, something that I don't know how I would do this today in JPA 2 and EJB 3.1. This is where I have two entity managers. Okay, I have two. It could be something else. It could be a JMSQ. It could be all kinds. But I have two entity managers, both of which, of course, deal with transactional resources. They have connections. The first one, EM, is unsynchronized. He is not connected to the JTA transaction that's going on here. There are transactions in all the methods. I have a second entity manager here injected called data mining EM. Okay, so I have a second. So I have two of them. One's connected to the transaction, and one of them's not. So, same as before, I'm in a shopping cart. I find the user, a customer, I create an order. I go back and forth with the user, the person shopping. But what I can do in the find books by author, say, and find books by subject, I can use the data mining EM to maybe build up a profile. So every time you go shopping on the website, there's the shopping activity, which is one entity manager, and the other entity manager is used for really your profile. You know, oh, he likes books about science or whatever your searches are for. We build that up, and if we were to use the data mining mining EM to add a browsed topic. And then at the end of that transaction, it'll be committed to disk. It'll go database. It's down there. And all these searches I'm doing are being logged. Yet it has nothing to do with the ND manager I'm using for shopping, right? It's separate, like having a separate connection, right? There's two different things going on here. Add to cart is the same as before. When they go to view cart, for example, I could use the data mining EM to go and look at their prior viewing history and give them some suggestions. So, oh, in your cart you've got A and B, but maybe you haven't thought of, given our knowledge of what you look for, these other books you might want to buy, right? So I can use that data mined data for something else. And then finally, when they say, oh, well, I'm going to buy this, again, we take the unsynchronized ND manager, we join the transaction, and we commit that change. So I have multiple ND managers in the same transactional EJB, yet which are behaving quite differently. And that's a new feature, this unsynchronized feature. And this is probably been a long time in coming, actually, to get this feature in here. The spec covers this, and I was going to show you since I'm here. So here's the latest version of the spec. It's just come out a few weeks ago. What's the date on this guy? October 26th, so it's quite new. Early Draft 2 is out. So if you want more info on these features, they do go through examples and explain it, because this whole unsynchronized, synchronized stuff, there's details and nuances, and so it's all captured in here. I wouldn't say the spec is written as like a how-to guide. It's written for implementers, pretty much, but some of it is actually quite clear. And so if you find the feature you're looking for, like if you Google or you search in here for unsynchronized, you'll find explanation of this, and it'll go through it again. And you'll find explanation of this, and it'll go through it again in more detail. Because I think it certainly took me a couple of times to get it straight as to the semantics of some of the subtleties here. Okay, so a few of the query enhancements. To check my time. So as we know, JPA has JPQL, and in JPA 2 it was enhanced a little bit, and we're adding more enhancements to the query language. Also enhancements around the criteria queries that were introduced in JPA 2 are coming in JPA 2.1. First is inclusion of an on clause. So currently we don't support on in JPQL, so we can only use where. So you have, for example, here an outer join between supplier and products with a where constraint. In JPA 2.1 we add on, and so the on, of course, is applied prior to the join, right? So applied to the target table. So you get a slightly different behavior between the on and the where. I'm not going to try and explain the implications here. I must say it's very hard to find someone who can explain to you clearly what on and where do. It's really actually surprisingly difficult, because it'd be nice actually for me to paste it in a small summary for you, but it's impossible to find such a thing. But it's basically the filters applied at a different point in the joining of the tables. And so if you know your SQL and you use on, it's now going to be available in JPQL. That's a minor feature, but useful. Downcasting, it looks like a cast, right? It looks like the idea is, if in the first sample here, I'm going to select from a book the name and its ISBN, and I'm going to select from books who are joined to who are part of an order, and that order is shipped. So the problem is that if you look at the O.product could be any number of things, right? It could be books, it could be CDs, DVDs. I don't know what you're buying, right? It's in your shopping cart again. But what we want to do is we want to find the ISBN and the name of things that are books that you've ordered. And so the treat here says treat O.product as book. So it looks like a cast, but really what it is, it's a filter, right? So if you think about it, if you're using like joined inheritance or some other JPQL or JPA inheritance mapping structure, let's say you have a single table. So you have a table full of products, and they'll have a discriminator column telling you what this thing is. If you think about it, what this really says is, I want to query from order, I want to join to the products, but only those which are books, right? I only want to filter on the books, and now I know that I've got books, I can look at their ISBN and their name, so it's a valid thing to do. So really it's a clever way of actually filtering the data down to the subset or the subclass that you're looking for, but it reads like a cast. Better to think of it as a filter. And the second one is actually really interesting syntax. It looks even more like a cast, actually, in this case. Find me the employees where if they're an exempt employee, let's look at their salary, and if they're a contractor, look at their rate. So we're saying, and again, think of it as a filter, select from employee where if their discriminator column or indicator tells me they're exempt, then I want to apply a certain check on the salary. Or if we can see from their discriminator column, say, that they're a contractor, I want to look at the rate. So this is actually, it makes sense. I think the syntax is really interesting here, where they have the dot notation on the treat, because it reads, again, more like a cast. But this lets you filter down and focus on subsets of data, which is really, really interesting and a useful feature. There's invocation of functions, general function invocation. We added this in EclipseLink. We called it func, but basically the same functionality. You want to invoke a database function, commonly required. Now it's going to be in the spec, and it'll be called function. You can invoke any arbitrary database function. You can put it in the where clause, as in the first sample, or in the select clause, as in the second one. So you can select standard deviation of the salaries, etc. So these are just useful things. The thing is that the database has, sometimes, there are functions you have to invoke. There are stored procedures you need to interact with. Your DBA says, you will call this, right? I often tell people, you'll be told in your company, there's some functionality and you must call this. This is the SQL we want to see. And so there has to be ways for you to get at that from your JPA application, not just go, gosh, we're doing ORM, we can't do that. That's not going to fly, right? Sorry, very loud. Bulk updates. Bulk update is where I can just wholesale change data, right? It's like a big, it's update. Update all the employees whose address building is 14 and their address is city is Santa Clara and their purchase is Java E, and set their address to building 22. I actually think this is a real example because there's an Oracle campus in Santa Clara, and I have a feeling the Java E team may have moved. That's what I'm thinking here. But this will go ahead and it'll just do a database change directly. And the side effect of this will also be that it will clear caches. So if you've got cached employees, we've basically sent some SQL to the database to do a massive change. So anything we have in cache, if you have a cache, is suspect, and so we'll actually invalidate the caches. So there's a side effect to these kind of bulk updates, but they're fairly efficient, right? They're doing a bulk change on database. I didn't have to read all the employees who match the criteria, modify them, and put them back. I just applied a change. The change here in JPA 2.1 is that we can now interact with embeddables. So employees clearly have their address as part of the same row as the employee stored in, and we've modeled it as an embeddable class with city and building. And we're now able to actually interact, or in a bulk update, refer to those embedded fields. So we can go in and query on them, and change them for that matter. So that's a minor but useful upgrade. The criteria API. Anyone using criteria API? Anyone? Okay. You're probably crazy, but no. Almost no one uses criteria API as far as I can tell. I ask everyone, and if you're using it, you should probably only be using it because you don't know up front what the query is going to be, right? So you've got forms, people fill in some forms, and you get some criteria, and you have to basically build a query. So criteria API is great for building a query that you don't know in advance. If you know what the query is, and it's just parameterized, I would use JPQL, and almost everyone I know would use JPQL. And there are those who would argue that the criteria API is better because it's type safe, and that's probably true. I agree. The problem is it's completely unreadable, right? So it's a trade-off: correctness, readability. And what you're finding today in the latest round of IDEs, Eclipse, NetBeans, and JDeveloper, at least, are all using the Hermes parser that comes out of EclipseLink project. So we have a parser we're using at runtime, and it's used at design time, so it can do things like type check and check your JPQL queries at design time. So you're sitting there in Eclipse and you're typing JPQL, you get code completion for JPQL that's correct, and then it'll also statically analyze your queries to make sure they're correct. So the value of static typing is good, but we're seeing more of that coming on the tooling side. And while the criteria API is totally necessary, and it was actually a major issue for Hibernate people to move from JPA, from Hibernate to JPA, until criteria API appeared, it really was a barrier. So it does solve a certain problem. And given that it's a real thing, although like I say, I really very rarely have to use it myself. It has been enhanced a little bit here in JPA 2.1. So we're getting criteria bulk updates and deletes, which weren't there before. If you notice on the third line of this sample, we have criteria builder dot create criteria update. So we're going to build a criteria update object that's going to let us do an update on employee. And then you see below here the syntax. We go and find the root object, which is employee. And we're going to set the employee salary to the product of the employee salary times 1.1, where the employee department's name is sales. Right? So we're going to just go ahead and apply that change to all of them. So it's really much the same as what we had before in the JPQL, or similar to that, but with criteria API support now. And the same is true with delete. So we can go and do a create criteria delete, get a criteria delete object, and then do the same thing, right? Bulk apply. So this is good. So don't take it personally if I'm dissing criteria API, because it is actually really important, but it is hard to use. And I challenge anyone to find anyone in the JPA expert group who could sit and write criteria API queries off the top of their head. I bet you they look it up, because it's tricky. Some of them can do it. I know some who can't. Okay, stored procedure invocation. This is something that seems like an obvious thing to have. And it's coming to JPA 2.1. So we're going to allow or provide a way to invoke stored procedures. Simple as that. It's tricky because, of course, it varies by database, but it's going to have to be supported. And we introduce a new name stored procedure query annotation here to allow you to declare these and then invoke them using the standard, but using the entity manager to instantiate an instance of that query and execute it. There's also support for defining these dynamically. So on the fly, there's API for creating them too. So here's an example. It's annotations that can be a little bit verbose. Name stored procedure query has a procedure name. So the procedure name is a database name versus the name, which is a logical name we use for looking up this query when we want to execute it. There's some in and out parameters here, and we have result class, and we'll talk about that. The trick is, if you invoke a query, any kind of native query, SQL query, stored procedure, what do you do with the results, right? Today it's not, in JPA 2, it's actually not that great, and there's some features we've got now. But this is just for shorthand. Know that if I have result class as raise history, I'm going to get a raise history class back from this query, and I'll explain how we do that in a sec. So this is fairly straightforward. And sometime coming again in EclipseLink, we have name stored procedure. Is pretty much the same thing. It works just the same way. Here's the invocation of it. So I have on the third line, em.create name stored procedure query. And these are big names, right? And we use the logical name, set the parameters, execute it, get results, get the output parameters. So it's not rocket science, right? It's pretty much what you'd expect. The dynamic API looks like this. So I can go and I can create a stored procedure query. In this case, I give it instance dynamic, right? I create an instance of this thing on the fly. It's like creating a create stored procedure query. It's like create native query. It's just inline in your code. Here's the name of the procedure I want to call, the result class, and then I have the in and out parameters, and I pass them in and execute as before. So you can do it either named or dynamically in your code. So let's talk about the results. It applies to SQL. I should have had this before the previous couple of slides on stored procedures. But when you invoke a named query, a native query, you want to deal with the results easily. And in the past, it's been, I would say, problematic. And I know that I actually, someone asked me about this, and I wrote a little how-to and a little blog about how to do a native SQL query and get back to just Java beans, right? If you've seen the constructor query syntax for JPA, you can say select new some object argument where you select them. This is all JPQL, right? So select some fields from objects and package them into a nice little instance for me to deal with. It doesn't actually, we didn't in the past, prior to 2.1, have that ability for native queries out of the box. So myself and others have sort of hacked little solutions together. Now what we have is a way to say, in this case, select me the ID, name, and the count of order count, and the average price, and package them up into a result, into a customer details result, whatever that is. Right, so we're going to actually take these results, not get back 4 pieces of info. We're going to get back the data packaged in a nice way I can consume it. So let's look at this. So customer details result is a string which identifies this SQL result set map. So you see here I have the name. I have a constructor result. And constructor result says, if you're using this result set map, we're going to instantiate an instance of customer details class, which is just some Java bean class, not an entity. It's just a Java bean, just Java class. And the constructor for customer details is going to be invoked with the columns in this order: ID, name, order count, average order. Right. So that's why over here you saw there were aliases defined for us to easily access these values. So average O.price was given an alias, so we could refer to it here easily as a column result. So if things don't line up, things are going to go badly for you. If the types don't match, things will go badly for you. So it's kind of up to you to get it right. But if you're going to define some native SQL queries, you can define a nice little Java bean constructor result here to let you build objects. It's easier to have the objects, right? And then you can access them by name. So this is a nice little feature. And there's more actually around this that we can do. Here's an example with an embeddable. So you can refer to embeddables. It's very much the same kind of thing. Select a bunch of stuff. I have a customer here. And I have city, street, and state. All these things are on the customer row. But in our Java, we've modeled it as embeddables again. So I have a customer results down here for my result map. And you'll see here that I've actually got an entity this time. So I said I've got, if you look down there under entities equals at entity result, it says I'm actually going to build an entity from this native SQL query. The class is customer. And then I map, this time, field results, right? So I'm mapping not just the columns, I'm mapping the fields to the columns. So ID is coming from customer ID. And then the embeddable address.street is also coming from a certain column. So I'm actually able to build not just the top level entity, but also build out the embeddables from my native SQL query. So this is a nice feature. Again, because sometimes, as in here, sometimes your DBA may say to you, you must use this piece of SQL. We've tuned it the heck out of it. It's the best piece of SQL. This is the SQL you must use. But you don't care about SQL. You care about your object. So using this mechanism is fairly declarative as to how to build the results you want from that piece of SQL you're executing. So it's a useful feature. It really is. The old stuff, I must say, has never really sunk into me, I must say. Too many annotations. In fact, I don't know what the annotation to content ratio here is, but there's a lot of them. Oh, okay, and then this is, you can dynamically define named queries now. I don't know what the big driver for this was, but you can get the entity manager factory here, and you can define a named query. So rather than having the at named query annotation on a class somewhere, or named queries in an XML files, you can dynamically define a named query. I can actually think of use cases for this. It could be that by context, somehow you know something about your environment that you want to create a certain query a certain way. And actually, I did have one person I was talking to who was talking about moving between different database technologies, and they wanted to tweak something. And this is a good example of that, where at boot up time they could figure out, oh, I'm on DB2, therefore this query could take advantage of something, and somehow the SQL for this named query was different. So you could create it here on the fly, it get registered, and then you can refer to it by name in your code. So all your code that uses a named query would always say create named query supplier status, right, the first argument. It would never see the actual query itself. So this is not a bad way of being able to sort of publish these things on the fly. It's useful in some cases, I guess. And this is a topic. Okay, this is a new topic. This is kind of we're kind of done with the query extension. This is sort of I didn't want to put miscellaneous, but there's a couple little things in here that I wanted to toss in. This is one that's been getting some interesting discussion on the expert group list, and now we're up to the point where it's sort of solidified. So the idea is that in JPA you can have entity lifecycle listeners. You can have listener classes that get callbacks. Well, in JPA there's callbacks on the lifecycle events, right? So pre-commit, post-destroy, or maybe I'm getting confused now with CDI. But pre-update, there's a number of different lifecycle callbacks you can put on an entity, or you can have them called on a listener class. So you can plug in a listener who gets callbacks whenever the entity goes through certain lifecycle changes, pre-commit, post pre-update, etc. And so the problem was that those classes are being instantiated by the JPA provider, but you couldn't use CDI. You couldn't actually plug anything into these objects. They're not actually managed by the CDI container. And so this is sort of a halfway step between sort of letting CDI take over, because JPA has its own little world, right? And actually Jan was talking about JAX-RS earlier, and I certainly have found it a challenge in EJB6 or EE6 when you're dealing with JAX-RS, CDI, EJB, and JPA. They all have their own little life cycles going on. They're trying to fix this up in EE7, try to unify them a little bit better, because I've run into cases where you're using certain things aren't initialized when you think they should be, basically. So what's happening here is JPA providers are going to use the CDI API to construct or interact with CDI to obtain managed beans and inject them into the listeners. So these objects are not going to be injected by CDI themselves. They're going to be constructed by the JPA provider talking to CDI. And I think maybe we'll just look at the sample here. We'll give you a better idea. So here's a bank account, and it's an entity, and it has a listener attached to it called account alarm. And this guy's just monitoring. You see here he's looking at post persist in the bottom there. He has an at post persist on account alert. So whenever a bank account is committed to disk and it's persisted, it's attached, then we're going to get a callback here. And in that callback, we can do whatever we want. Now, in the past, lacking any kind of injection, you're kind of on your own. Like, what do you do, right? So this account alarm instance is instantiated by JPA, and it has no context. It knows nothing. It doesn't even have a reference to the entity manager, which I found really strange too. It really has context free. What can it do? So with this change, with injection of listeners into listeners, you see the at inject for alert mailer there. So the at inject is CDI annotation. What's happening is JPA is going to provider is going to instantiate the account alarm as it's required to do to plug it in as a listener. But when it does that, it's going to look at this at the properties and the methods. It'll see the at inject and say they're requesting injection of a mail session of type with a qualifier saying alert mailer. It'll speak to the CDI container to get the appropriate one for the context and inject it for you. So it's kind of like a little bit of a bridge code, right? A bit of glue code here. Because these objects are being instantiated by JPA and they're not managed by CDI, there's kind of a plug into CDI to get some context. So this is a good first step, and it's kind of interesting because it's kind of a problem that lurks throughout EE, where CDI is doing certain things and the other models are doing other things. And again, like I say, they're working to make a more unified, grand unified field theory type thing out of this. But this is a step on the way. So if you need to do things in your listeners, you can actually inject resources to do so, which is a big improvement. Okay, how's that look? Okay, so this is the current status. So this is a screenshot off of the wiki, the EclipseLink wiki. EclipseLink is the JPA 2.1 reference implementation. So we're tracking the spec. If you know how these things work, every JSR has a document, a piece of paper, like I showed you that piece of paper, and there's reference implementation. The reference implementation proves that what's on the paper is realistic. Because anyone can write anything about a specification, but if you can't do it, there's no point in having such a thing, right? So every spec has a reference implementation, and every reference implementation must be working and ready to go for the spec to be finalized. And so you have this nice feedback between sort of the theory and the practice. So the EclipseLink team is busy implementing features that are sort of stable within the JPA 2.1 spec. So some things are move back and forth and there's discussion, but some things are like they're done, they're in the spec. They're drafts, they might change. They're in that whole thing is a draft, so technically anything could change. But a lot of stuff is pretty stable and they've gone ahead. So this is the top level bugs. If you Google EclipseLink JPA 2.1, you'll hit this page. You can see that a lot of them are in progress, some are completed, some of them are new and haven't been addressed yet. But of the things we spoke about, you can see here the stored procedure queries they're currently in progress. The criteria bulk API stuff is done. So if you're interested in playing with that, you can go and you can download EclipseLink. The 2.5 branch, I think I have it later on the end here. JPA 2.5 is targeting, this is complicated, JPA 2.1. So we've branched EclipseLink. There's sort of a maintenance release, 2.4 is in maintenance, and there's some minor features. But the 2.5 is trunk, or it's main, and it's doing JPA 2.1 work. So if you go and get the latest nightly build of EclipseLink 2.5, you're going to get whatever you can play with in terms of what's finished so far for JPA 2.1. And I think the next slide lays it out. Yeah. So EclipseLink.org, of course, you can get there. This is part of EE7. And EE7 has been retargeted for spring of 2013. It was sliding out, and if you follow all the discussions, they were able to trim the scope and bring it back in closer by mostly deferring the cloud stuff. So all the stuff to the cloud, which had a big impact on JPA, because within JPA 2.1 there was much discussion around multi-tenancy and tenant isolation. And I was actually here last year talking about the EclipseLink work in tenant isolation that we're shipping now. It's been shipping for a while now. And there was work to standardize tenant isolation as part of the EE sort of cloud initiative. And since cloud's been deferred, that work's been moved out of JPA 2.1. So if you look at the draft, there's nothing in there about multi-tenancy or about the cloud stuff. It's basically been put on the shelf. When we rev EE to go to EE8, and the next JPA JSR is started up, that cloud stuff will come back off the shelf. The nice part is they talked about it a lot. They worked out a lot of the issues. They're just not including that stuff in JPA 2.1. So the release is date-driven. So again, it's time-boxed. We're going to do what we can within this release, which means that they're not going to be adding lots of big features to JPA because the time is limited, right? So they can only sort of. It's a discussion between, I guess, the RI team, the EclipseLink team, and the expert group. The expert group can invent some features, and we can say that's going to be a 6-month feature. And they go, well, that's impossible because we have to ship this. So because they have to have a concrete RI, everyone's involved in the conversation as to what makes sense, I guess. So we're heading for a spring release, but it'll be all part of the E7 release. So when E7 is done, JPA 2.1 is done, they all kind of go out together, right? If you're interested in following more details, the expert groups, they really renovated the JCP. So all the expert group chatter is in public. You can see what they're talking about. You can see the discussions back and forth, arguments made for or against certain features. You're welcome to go and subscribe to these lists. And you see at the very bottom there, the JSR is 338. Excuse me. 338. If you go to jcp.org and you go for go on the left-hand side where it says search, you put in 338, it'll take you to the page. You can bring down drafts, etc., and look at these things. So that's the document you can get there. So these aren't like revolutionary features. I would say they're evolutionary features. And I think that we can feel good about them because the features that are going into the spec are the things we're seeing anyway. People are doing this in Hibernate, in EclipseLink, in OpenJPA. This stuff is happening. So might as well have a standard for this, and we can all have more portability. So I hope you're looking forward to this. I know I'd be happy to get some things standardized that weren't before. And I think, shameless plug, the mic's over there if you have questions. But Thursday, I'll talk about a talk called The Evolution of Java Persistence. And it's not about JPA 2.1 specifically. It's about a number of the things that we're pushing on in the EclipseLink project in terms of evolution. So JSON integration, JAX-B integration, NoSQL database support, all kinds of stuff that's kind of on the where we're evolving to. It's not standardized yet, but if you're using persistence products out there, you might be interested in sort of where we're going with these things, because we have a lot of cool technologies in the lab and also shipping. So that's Thursday at noon. I think that's all. Okay. So there's a mic over here where you can shout very loud if you have a question about anything. No? No questions. Okay, well, it's pretty geeky, I know. So, okay, well, download the spec. Look at that. There are two lists. There's the expert group list, and there's kind of the observer list, and you can post to the observer list. So if you have questions or comments on anything, you can go to that list and make your comments directly, and the expert group, of course, subscribes. Technically, they're not required to read that list, I think it says in the rules, but they do. So if you have feedback, they'd welcome it. Thank you.